students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn RAS-score formula and comparison of T and F test. What are you going to learn in this lesson? Let us look at the learning objectives. After completing this module, the students will be able to apply the one-way ANOVA in an easier way with less mathematical computations using RAS-score formula. The students will be able to understand the relationship between T and F test and compare the two tests with numerical application. Few additional concepts in one-way ANOVA. Let us start. We begin with the first part of the lesson, in which you will learn the RAS-score formula for one-way ANOVA. What is RAS-score formula for ANOVA? So, in the previous lesson, we have learned how to perform the one-way ANOVA procedure. In the one-way ANOVA approach, we obtained the test statistic F based on sum of squares which used deviation of scores from overall mean or group mean. Here we propose an easier way of computing F statistic. Let us compare the classical sum of squares calculation with the RAS-score formula calculation. Let us begin with within sum of squares formula. So, which is nothing but you are going to take the square of sum of deviation of all the observation in the first group from the first group mean, and you move to the square of sum of deviation of observation from the second group mean, so on up to you move up to whatever number of treatment you have. So, if you have k treatment, you need to repeat this and you have to take a labor to find out the total within sum of squares. Now, I will tell how this formula can be reduced by using a RAS-score formula. So, the within sum of squares using the RAS-score formula will go like this. Instead of finding out the deviation and then squaring and then sum in all the groups, you can directly take out all the observation and you can square it and you can sum. So, basically when you have observations in your group, irrespective of the group, you are going to square the observation and you are going to take the sum. So, this is what your first term. Your second term is you are going to take the sum of observation in the first group, then you are going to take the square of that total divided by what is the size of the first group, that you will put here. Similarly, the second term will be the sum of observation in the second group and you take the square of that sum divided by the size of the second group. Like this, you will continue for the number of groups you have. Similarly, what is the classical formula for between sum of squares is you have to take the product of the size into the square of deviation of each group mean from the overall mean. So, you have to expand it for all the treatment you have, then only finally you will get SSB, but using RAS-score formula you can easily get it without going to the deviations. So, firstly you are going to find out all this term. So, look at the within sum of squares, whatever is in the second term that you are going to put in the first term. So, you have to take the sum of observation in the first group and you are going to take the square of the sum divided by size of the group. Likewise, you move for every other group minus g square by n. So, g square is nothing but the total of all the observation in your sample irrespective of the group. Then you have to square the total of observation divided by n. N is nothing but sum of all the observations. So, sum of n1, n2 up to nk. Similarly, for total we had a complex formula like this, and for this our sum of squares formula will reduce us to squares of the observation, and you have to take the sum of all the squares of observation, and then the second formula remains the same. The second term remains the same, similar to the between sum of squares. For explaining the RAS-score calculation, we are going to relook at the case scenario we have introduced in the previous lesson. So, this scenario is about a dentist is comparing the three different pain management technique: storytelling, musical audio and audio visual group. With the same example, we are going to work out this RAS-score formula. So, first we will calculate the within sum of squares using RAS-score formula. So, the first term is, so this is the data. So, just for the comparison purpose, I have acronymed the first group as storytelling audio as SA, musical audio is MA and audio visual as AV. So, SA, MA and AV are the datas from the 3 different groups, and the next column, the second column corresponding to the square of the first column. So, because we want the square of all the observation in the first term. So, for computing the first term, we need the square of the observation, that is square of SA. So, I have continued with the second group, the square of the second group, third group and the square of the third group. So, the square of 22 is 484, the square of 23 is 529, like that we will continue and find out the sum of all the squares of observation, which we will get by adding 3838 plus 10220 plus 526. So, when we total these 3 observation, total of second column, fourth column and sixth column, we will get 14584 minus the second term is nothing but the first term of the second term is the sum of the first group, that is the sum of SA, that is 128, that square divided by size of the first group. So, we have 5 observation, so 5. Similarly, we go for the sum of the second group, which is 222, square the term divided by size is 5. Similarly, move to the third group. Likewise, we can move to whatever number of groups we have. So, in this example, we had only 3 groups. So, we have stopped up to 3. So, now while doing a simple computations, we will get a sum of within sum of squares as 989.6. Now, we will move to compute the between group sum of squares using the Roscoe formula. So, as I said, the difference between the within and between sum of squares is the second term in within sum of squares moved to the first term of between sum of squares. So, this is the data. So, this is the data and we are going to find out the sum of the first group, which is 128, the whole square divided by size of the group is 5. Similarly, the sum of the second group is 222 and we are going to divide by the number of observations. Similarly, the third group we will putting 48 divided by 5. So, with a simple computation we will get 3034 and this 398 is nothing but the total of all the observation together. So, we will end up with 3034.1. Now, we will move to Roscoe computation of total sum of squares. So, here it is the square of sum of all the observation minus g square by n. In some textbooks you will refer this term as a correction factor, but I am not bringing that name because already the formula is so complex. So, just you can remember like summation yij square minus g square by n. So, where g is the grand total of all scores and n is the total sample size and this is the data. And when you take all the 3 groups here for the purpose of the space only 2 group is mentioned, you assume that there is a third group also. So, 14584 is nothing but the total of all the observations together and 398 is nothing but the 14584 is the sum of squares of all the observation, 398 is the sum of all the observation and then you are going to take the square divided by total number of observations 15. So, you will get 1808. So, from the Roscoe calculations of all the total within and between sum of squares, we are going to form a ANOVA table. So, in which the first column of ANOVA table is a source of variation. So, what is the source of variation? One is between variation and another one is within variation and total variation. So, we are going to enter the values what we have calculated. So, the sum of squares for treatment is 3034.1, the sum of squares for error is 989.6, the total sum of squares is 4023.7. So, there are 3 treatments. So, the degrees of freedom for treatment is 2. So, there are totally 15 observation. So, n minus 1 is 14 and by subtracting 2 from 14 we will get 12, which is the error degrees of freedom. And the mean sum of squares we will calculate based on dividing the sum of squares by the corresponding degrees of freedom. So, when we divide 3034.1 divided by 2 we will get 1517.1 and again if we divide 989.6 by 12 we will get 82.5 and again by dividing the mean sum of squares for treatment by mean sum of squares for error we will get the F ratio. So, this is what the raw-square computations based on a very simpler mathematical formula. So, the ANOVA table whatever we have obtained using raw-square formula and the classical method is exactly same. In this video, we have learned a computationally easier method of working out one-way ANOVA called raw-square formula for one-way ANOVA. We have worked the answer example with this formula and proved the results are exactly same. I hope the concepts are clear to you. We will continue in the next video. Thank you.